Ever asked an AI for something simple, only to get a response that's so off base it's almost funny? Like asking for bonds in Australia and getting data about US instead. That's not just a glitch, it's a symptom of a bigger issue: parameter failures in AI systems. Today, we're diving into a groundbreaking study that's uncovering how these tiny errors can create huge problems, like a butterfly flapping its wings and causing a storm. So what's a tool agent? Think of it as an AI assistant that uses multiple tools to solve complex tasks. For example, if you ask it to find bonds in Australia, it might first search for related terms, then pull data from a database. But here's the catch: these systems rely on parameters like region or query to work correctly. If the AI gets those wrong, the whole chain of tools can fail. The researchers behind this study call this the butterfly effect in toolchains. A small mistake in one parameter, like using Australia instead of the abbreviation O, can derail the entire process. Imagine asking for weather in Sydney, but the tool thinks you meant Sydney, Canada because of a typo. That's not just confusing, it's a critical flaw in AI systems we're starting to rely on more and more. To understand this better, the team analyzed how AI models like ToolLLaMa handle parameter inputs. They created a failure taxonomy, a classification of common errors, by studying thousands of tool interactions. Using a method called grounded theory, they looked for patterns in how AI misinterprets user queries, tool documents, or return results. This approach allowed them to identify recurring issues through iterative analysis. Their analysis revealed 5 key failure categories. 1. Missing information. The AI forgets to include a required parameter, like leaving out region entirely. 2. Redundant information. It adds extra parameters that aren't needed, like specifying US when AU is required. 3. Parameter hallucination. The AI makes up parameters that don't exist, like inventing a country code that the tool doesn't recognize. 4. Format mismatches. It uses the wrong data type, such as a number instead of a string. 5. Context drift. The AI loses track of the task's goal, like switching from bonds to stocks mid-process. In one experiment, the team tested how AI responds to slightly altered inputs. For instance, changing Australia to AUS or AU caused failures in tool calls. They found that LLM limitations, like over-reliance on patterns, often led to errors. For example, when asked, "Is Alex a boy or a girl?" the AI might default to gendered assumptions without considering that Alex is a gender-neutral name. But here's where things get tricky. Some errors aren't just typos. Take parameter hallucination, when the AI invents data that doesn't exist. Imagine it creating a fictional board called Mu to answer a query. These aren't random flukes. They expose how AI struggles with ambiguity and real-world complexity. To test these theories, researchers designed experiments that deliberately attack AI systems. They removed parameter descriptions, swapped data types, or messed with formatting. By forcing errors, they mapped out exactly how AI fails and how to fix it. For example, when a tool expected a string but received a number, the system crashed. These tests revealed the need for robust error-handling mechanisms. The takeaway: building AI that can handle chaos isn't optional, it's essential. Without tools to recover from errors, AI could spiral into disaster. Whether it's a missing comma or a weird input, these safeguards help AI adapt, or at least fail in a way that's safe and understandable. So next time you see an AI stumble, remember, it's not just a glitch. It's a chance to build something smarter. Want to see how these tests actually work? We'll dive into the experiments that uncovered these secrets and what they mean for AI's future. Stay with us,